Hello everyone, today I'm going to go over what is binary search and going to practice with coding interview question using the binary search. Well, how will you find the number 7 here in sorted array? Brute forcefully, you can go from the first item to the last item like this, and you will eventually find 7 at the last item. In this case, the time complexity in worst case is order n. Think about every time you select item takes 1 second. It will take 7 seconds. So let's take a look how the binary search works here. In sorted array, binary search is very powerful. So you basically select the middle item in the sorted array. In this case, 0 is the first item and 7 is the last item. So 3 is the middle item and ask if this item is number 7. It's not, but we for sure 3 is less than 7, so now we just interested in from 4 to 7. So what is the middle item from 4 to 7? Is 5. So we ask the 5 is equal to 7 or not. It's not, but we for sure 5 is less than 7, so we now just interested in 6 and 7 here. The middle item of 6 and 7 is 6, and we eventually find number 7. So the worst case here is order log n, which is faster than order n here. This is binary search. So let's take a look at the practical example here. We have the build system and we want to find the first failed build from the log here. In this case, the number 4, so index wise is number 3, right? 0, 1, 2, 3 is the first failed build. How we can find it? Using the binary search, we can find it in log n time. So let's take a look. Our basic example is here, how we can apply the binary search here. We basically want to find the index here using the binary search. And firstly, we need the middle item here. So in order to have the middle item, we want to have the first index is 0 here, and the last index of this one is length of input minus 1, right? And we want to give the input value so we can calculate this one in our binary search function. Okay, let's create a binary search function here. So I got the input array, which is sorted, and the left item and right item here. So basically we want to have the middle item here using the L plus R, and the divided by 2 is the middle item. And if the input middle item is the failed build, then we want to assign the right item with middle item. And if not, if it is successful build, I'm going to assign this mid plus 1 as left item. What it means here, if the middle item is a failed build, then it may or may not the first failed build. So we still interested in this index. That's why I include this index in the next round here. But if it was the successful build, then we are not interested in this index. That's why I exclude this index in the next round. So L is middle plus 1 index here. So I set round here. So we have the while loop here. While the left is less than right item, I'm doing these things iteratively until left and right is same. From this here, right or left is going to be assigned with a new middle value or middle plus 1. Eventually we will have the left and right is same, or left is greater than right maybe. Okay, here. So here return L if input L is F. If input L is F, then I just return L. Else minus 1. Minus 1 means there is no failed build here. Also, let's have the edge case here. If length of input is less than 1, there's no item, that means there is no failed build here. So return minus 1. Alright, shift enter and shift enter. Okay, let's print this index here. Print index. Then you can see 3. So you can see the first, so 0, 1, 2, 3. As you can see, the first failed build is 3. It works very well. So let me see another example from here. So if we have the only failed build means here just F, 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 and F. In this case, should return 0. Okay, cool. And if we have the just 0, just nothing in the array, then they should return -1. Okay, this is almost of my tutorial today. Well, you can go to my GitHub website here and practice yourself. Thank you for watching, and I will see you on the next video.